This program will present the controls and indicators, landing gear, nose wheel steering, normal brakes, alternate brakes, and auto brakes. The landing gear controls and indicators are located on the captain's instrument panel, the center instrument panel, the first officer's panel, the left sidewall, the control stand, and the rudder pedals. The landing gear lever is located on the center instrument panel. Red and green landing gear indicator lights for gear position are located above the lever. The landing gear lever has 3 positions: up, off, and down. A placard below the handle displays the landing gear limit speeds. Maximum gear extend speed is 270 knots, or 0.82 Mach. Maximum gear retract speed is 235 knots. Maximum speed with the gear extended is 320 knots, or 0.82 Mach. Manual gear extension handles are located on the cockpit floor to the left of the first officer's seat. To the left of the landing gear lever are the anti-skid and auto brake controls and indicators. The anti-skid system has a guarded switch and an amber anti-skid in-op light. The auto brake system has an auto brake select switch and an amber auto brake disarm light. A hydraulic brake pressure indicator is located on the first officer's instrument panel. Normal system pressure is 3,000 psi. The nose gear steering wheel is located on the captain's side panel. The alternate nose wheel steering switch is located on the captain's instrument panel. Rudder pedal steering is also provided. Manual control of the wheel brakes is provided through toe pressure on the rudder pedals. The parking brake lever and red parking brake warning light are located on the control stand. With a review of the controls and indicators complete, we are ready to discuss the landing gear. In normal operation, the landing gear is powered by hydraulic system A. Hydraulic system B can raise the gear through the landing gear transfer unit. The 737 has a dual-wheel tricycle landing gear. The gear retracts into the fuselage to reduce drag. Doors attached to the main gear struts provide cover for the wing and portions of the fuselage openings when the main gear are retracted. Rubber blade seals contact the main gear tires on the outboard wheels to seal the openings when the gear are retracted. The nose gear doors are mechanically linked to the nose gear. There is no indication in the cockpit of nose gear door position. To raise the landing gear, first pull the landing gear lever out of the down detent. The red gear indicator lights illuminate, indicating a disagreement between lever and gear position. The green lights remain illuminated until the gear leaves the down and locked position. When the lever is placed to up and the landing gear leave the down and locked position, the green lights extinguish. The red lights remain illuminated, indicating the gear is in transit. As the main landing gear retracts, the brakes are automatically applied to stop the rotation of the main wheels. A snubber in the nose wheel well stops the rotation of the nose wheel. The nose gear is held in the up position by an over-centered link. The main gear is held by an up-lock hook. These are mechanical locks and do not require hydraulic pressure to hold the landing gear up and locked. When the landing gear is up and locked, the red indicator lights extinguish. After a minimum of 10 seconds, the landing gear lever may be placed to the off position. This removes hydraulic pressure from the landing gear system. There are several landing gear retraction safety features. When on the ground, a lever lock prevents gear lever movement to the up position. If the gear lever will not move to the up position after takeoff, pulling the override trigger bypasses the lever lock and allows the landing gear to be raised if necessary. Also after takeoff, if engine number 1 should fail, a landing gear transfer unit ensures there is sufficient hydraulic pressure to raise the landing gear. There are 3 conditions required for operation of the landing gear transfer unit. Number 1 engine N2 RPM below idle, landing gear not up, and the landing gear lever in the up position. To extend the landing gear lever is placed to down, the up locks are released, and the gear extends. The red lights illuminate while the gear is in transit. The red indicator lights extinguish, and the green lights illuminate for each gear when it reaches the down and locked position. The green lights are illuminated by switches on the mechanical down-lock mechanisms. Hydraulic pressure is not required to keep the gear down and locked. Answer B is correct. The maximum gear extend speed is 270 knots. These limitations are on the placard under the landing gear lever. Nose wheel steering is provided to maneuver the airplane on the ground. With the aircraft on the ground and the landing gear lever in the down position, hydraulic pressure is available for nose wheel steering through the landing gear hydraulic down line. When the nose wheel steering switch is in the norm position, System A hydraulic pressure provides power for steering. Placing the nose wheel steering switch to Alt provides System B hydraulic pressure for steering. In the event of a hydraulic leak downstream of the landing gear transfer unit, resulting in a loss of hydraulic System B fluid in the reservoir, a sensor closes the landing gear transfer valve and alternate steering will not be available. Rudder pedal steering turns the nose gear through a smaller angle than the nose gear steering wheel. The rudder pedals are used for nose wheel steering during runway alignments in takeoff and landing. As the nose wheel strut extends on takeoff, rudder pedal steering is deactivated. Steering actuators are mounted on the nose wheel strut. The steering depressurization valve is provided with a lockout pin. When the lockout pin is installed, the airplane may be towed with hydraulic System A pressurized. Without the pin installed, System A must be depressurized for towing operations. Do not attempt to taxi with the pin installed. The 737 has only main landing gear brakes. First, let's look at the normal brakes. Normal brake system operation consists of manual brakes and automatic brakes. Hydraulic System B powers the normal brakes. Metering valves control pressure to the brakes for manual operation. When operating, the auto brake control module supplies pressure to the brakes for automatic operation. Normal brakes are controlled by the rudder pedals through the brake metering valves. From the brake metering valves, normal brake pressure is supplied to each wheel and further controlled by anti-skid valves. Let's look at the control system for the anti-skid valves. Each wheel has a transducer which measures wheel speed. The anti-skid auto brake control unit receives inputs from each of the wheel speed transducers, which allows it to detect a skid or locked wheel condition. The anti-skid switch controls power to the anti-skid control unit. The anti-skid control unit regulates the anti-skid valves. With the anti-skid in-op light illuminated, the anti-skid system might be inoperative. Anti-skid protection is provided when the anti-skid in-op light is extinguished. Anti-skid protection is provided for each wheel in the event of a skid or a locked wheel. Touchdown protection is also provided. Pressing both brake pedals from either pilot's side and pulling up on the parking brake handle sets the parking brake and mechanically locks the pedals down. The red parking brake light illuminates. The anti-skid system is deactivated with the parking brake set. Let's now look at alternate brakes. Alternate brakes are controlled by the rudder pedals and powered by hydraulic system A. When system B pressure to the normal brake system is low, an alternate source selector valve opens to supply system A pressure to the alternate brake system. The system A pressure is controlled by alternate brake metering valves. From the alternate brake metering valves, system A pressure is directed through alternate anti-skid valves to each pair of dual wheels. The anti-skid auto brake control unit regulates the alternate anti-skid valves, and the valves are monitored by the anti-skid in-op light. A brake accumulator is also a source of brake pressure. The accumulator is normally pressurized by hydraulic system B to 3,000 psi. The accumulator holds a pre-charge of 1,000 psi, which the indicator will show when the accumulator hydraulic pressure is depleted. When system A and B pressure is lost, the accumulator isolation valve makes accumulator hydraulic pressure available to the brake metering valves. B is the correct answer. In the event of the loss of hydraulic system A and B, only accumulator hydraulic pressure is available for braking. After the accumulator hydraulic pressure is depleted, the indicator will read pre-charge only and no brakes are available. The auto brake system is used for automatic braking during landing or a rejected takeoff. Like the normal brake system, the auto brake system uses system B hydraulic pressure. The system controls pressure for the selected rate of deceleration through the auto brake control module. Pressure is then applied to the anti-skid valves for anti-skid control. The wheel speed transducers provide signals to the anti-skid auto brake control unit for wheel deceleration information. The auto brakes can initiate braking action faster than can a pilot. The most efficient braking action can be accomplished by use of auto brakes to initiate braking, followed by pilot-initiated reverse thrust and manual braking. Lower the nose gently to the runway with elevator control to lessen nose wheel impact. 4 deceleration rates can be selected. The maximum setting is less than full normal braking. Under normal landing conditions, the auto brake system will reduce brake pressure as reverse thrust becomes effective so that the total deceleration of reverse thrust plus braking is equal to the selected deceleration rate. The auto brake system must be armed prior to landing. When a deceleration rate is selected and the auto brake disarm light remains extinguished, it indicates the system is operational. After landing, when both thrust levers are retarded to idle and wheel spin-up has occurred, the auto brakes are applied. On the ground, applying pressure to either pilot's brake pedals will disarm the system. The auto brake disarm light will illuminate. Advancing one or both thrust levers will also disarm the system. Moving the speed brake lever to the down detent will also disarm the auto brake system. The auto brake disarm light extinguishes with the selector in the off position. In off, power is removed from the system. Now let's look at the rejected takeoff or RTO feature of the auto brake system. Prior to takeoff, the rejected takeoff mode is selected. The auto brake disarm light will illuminate for 1 to 2 seconds while self-test is in progress. If the test is satisfactory, the auto brake disarm light will extinguish and the system is armed and ready for operation. During takeoff, when speed is greater than 90 knots and both forward thrust levers are retarded, auto brakes are activated. Maximum braking with anti-skid protection is applied in the RTO mode. At liftoff, the auto brake system is disarmed, but the selector switch remains in the RTO position. The switch must be manually returned to off. Should RTO remain selected for landing, the auto brake system will disarm. Shortly after landing, the auto brake disarm light illuminates. Selecting off extinguishes the light. Answer B is correct. The auto brake disarm light illuminates for an RTO self-test. However, during normal system operation, the light will remain extinguished when selecting a landing deceleration rate. This concludes the presentation on the landing gear system.
Non-normal landing gear indications and procedures will be covered next. The wheel well fire warning light and master fire warning switches illuminate. The fire warning bell rings continuously. The first action is to silence the fire warning bell. The recall item for the wheel well fire is to slow the airplane below 270 knots maximum and lower the landing gear. Review the wheel well fire warning procedure in your operations manual. Answer C is correct. If possible, the airplane should proceed to the nearest suitable airport with the landing gear extended. If range is a factor and the landing gear must be retracted, ensure the fire is extinguished and the wheel well area has adequately cooled. Wait 20 minutes after the wheel well fire light has extinguished. Slow to 235 knots, then retract the gear. You are on the ground and the auto brake disarm light illuminates. Turn off the auto brakes. The light will extinguish. Do not attempt a takeoff with the auto brake disarm light illuminated. In flight, the auto brake disarm light illuminates. Turn off the auto brake switch, then reselect a deceleration rate. If the light re-illuminates, turn off the auto brakes and use manual brakes. The hydraulic brake pressure indicator reads 0. This indicates the accumulator has lost its precharge. Brake operation will not be affected with normal System A and B pressure. The anti-skid inoperative light illuminates. This indicates a fault has been detected by the self-test feature of the anti-skid system. Position the auto brake selector to off. Brake with caution. The landing gear lever cannot be moved to up after takeoff. Probable causes are failure of the air-ground safety sensor or a popped circuit breaker. A landing at the nearest suitable field is recommended. If this is not possible with the gear extended, pull the landing gear override trigger to bypass the safety solenoid and retract the gear on the captain's command. The manual gear extension procedure is used when one or more green landing gear light does not illuminate. Study the manual gear extension and partial or gear up landing procedures in your operations manual. Answer C is correct. For partial or gear up landing, flaps 40 is selected. This completes the landing gear non-normal presentation.